Now, remember, horizontal and vertical lines are very special lines. A vertical line has the equation x is equal to a. And remember, a is that one spot where it's crossing the x-axis. A vertical line is written in the equation in the form y is equal to b. What do I know about a vertical line? I know that its slope is undefined. And remember, when we're talking about parallel and perpendicular lines, we're always talking about their slopes. Horizontal lines, I know that its slope is always going to be 0. Okay, so let's keep that in mind, and let's come down here and let's say, what if I want to find the equation of the line that's parallel to x equals 3 and contains the point 1, 5. Well, first, let's go over here and draw this line, x equals 3. So I'm going to draw that in blue. X is equal to 3, which means that it's 1, 2, 3. It's this line right here. X is equal to 3. I can visually tell you that if I want a line parallel to this, it's going to be going up and down also. It's also going to be a vertical line. Well, if it's going to be a vertical line, I know it's going to be x is equal to something. I'm supposed to be going through the point 1, 5, so I'm going to use that x coordinate there, that x value, to tell you that the equation of the line is going to be x equals 1. So that is the line, x equals 1, that is parallel to x equals 3 and contains the point 1, 5. Let's just check. This is over 1, up 1, 2, 3, 4, 5. Yeah, it would be up there. Okay, let's look at this again. What if I want to find the equation of the line that's perpendicular to y equals 5 and passing through the point 2, 5? Perpendicular means that their slopes are going to be negative reciprocals. It also means they're going to form a right angle. You don't always want to just trust yourself on a picture, because pictures on graphs don't always tell the whole story. So we're going to do it mathematically. But the first thing I'm going to do is I'm going to draw the equation, the line y equals 5. Remember, this is a horizontal line. So I'm going to come up here and I'm at 5. 1, 2, 3, 4, 5. I'm going to draw a line, and that would be y is equal to 5. I know that if my line is y is equal to 5 and it's a horizontal line, then the slope is 0. The slope perpendicular to that would be negative 1 over 0, which is undefined. Right? So then I know that my new line is the only line that has a slope undefined is going to have to be x equals something. So I'm going to come up here and I'm going to pick my x coordinate at 2. And I'm going to say my new line has to be x equals 2. I'm going to draw that. Coming over here to 2. There we go. There is my x equals 2 line. And this line, x equals 2, does pass through the point over 2, up 5. It happens to be that line, that point right there. Okay, so the keys to this section on parallel and perpendicular lines, I'm going to scroll up here and make your eyeballs cross for just a second. Okay, parallel lines, their slopes are equal. Very important, that's the key. Their slopes are equal. Always put your equations in the slope-intercept formula so you can evaluate the slopes. Scroll down here. Perpendicular lines, then I know that when I multiply their slopes, I get that the product of their slopes is negative 1. Another way to think of this is the one slope is, let's say m1 is equal to negative 1 over m2. Okay, that's another way to draw it. Negative reciprocals. Okay, And you always want to put it in the y equals or the y-intercept formula, and find the slopes, be able to evaluate their slopes, and then we don't ever really get away from that point slope formula, because we're going to use it to create new lines, and that's what we're going to do in here when we need to talk about creating new lines that are perpendicular or parallel to our existing lines.